But earlier, the pendulum which used to vibrate was linked to the motion of the seconds and motion of the hands of the clock. So if the pendulum goes fast or slow, the time shown by the clock will also go fast or slow. So that is the question we are dealing with. Because suppose your clock is calibrated for winter, by the time it is summer, the length increases because of thermal expansion. And if it increases, your time period will increase. So what the clock, if it is supposed to do 2 seconds, one oscillation in 2 seconds, now suppose it does one oscillation is 2.1 seconds or 2.01 seconds, in the whole day there will be a lot of loss of time. You might say it is just 0.01, but no, in one day it has to go 86,400 times this and that, this way, that way. You have 86,400 seconds per day, so the clock should ideally do 86,400 times per day, but it will not. 0.01 every time it will lose. So 86,400 into 0.01 will be 864 seconds, which is more than 15, it is around 15 minutes, 14 minutes. So your clock will be slow by 14 or 15 minutes. So how to do that question is what we are exactly seeing now. Now here, just see what I am doing. The reason will be clear very soon. We take a log throughout. Log t equals log 2 pi plus half log L minus half log G. I write like that. What is d by dx of log x?
1 by x.
1 by x. Rather we write it like this. D log x is dx by x. We will use this. This is the natural log to the base e. ln I am writing. Yeah, you are used to that symbol, right? So I take a differential throughout. D log t equals d log 2 pi plus half d log L minus half d log G. Now d log t, d log x is dx by x, so this becomes dt by t. This is differential of a constant. D 2 pi will be 0. This is differential of gravity. Gravity at a given spot remains constant. It may differ when you go from place to place, but at a given spot it is 0. There is no change in gravity. So what you have is a change in this, which will be half dl by L. Well, to get this, you can differentiate directly, but you're taking a log and then differentiating it makes it easy. If you have some complicated products and divisions, taking the log and then taking the differential makes it easy. That's the idea. Now comes the situation. Here I'm calling dt as delta t and dl as delta L. Although it's not strictly true, delta t means a small change in time period. Dt means infinitesimal change. There is a difference between infinitesimal and small in terms of calculus. But we say it's more or less same. So I put delta t by t. That means, look here, what is delta t? Delta t will be half delta L by L into t. We know that, what is alpha, definition for alpha? Alpha is
1 by dl by dt.
Delta L by L. I'm not calling it delta t because t is for time period now. I'm calling it theta. Theta is change in temperature. The same thing. So, what is delta L by L? This is half alpha delta theta times t. Well, that's the idea. You will know how much time we lose in a day. If you want to calculate how much time we lose in a day, suppose the clock is correctly calibrated for winter. So in summer means summer winter temperature difference we'll have to check, maybe 20. So we'll put delta theta as 20. Alpha for whatever metal your pendulum is made up of. T means in single day, 86,400. Put these values, you will know how much time you lose. Your clock will go slow by that much amount. If pendulum becomes longer, time is lost and vice versa. That's it. I'm not talking about pendulum, I'm talking about the way this question is done. This is using differential approximation. When you put dt as delta t and dl as delta L, that is differential approximation. You have seen two kinds of approximation, differential approximation. In another way, we have done binomial approximation. Both these you know. I give you another question wherein you will be using the differential approximation once again. Nothing to do with pendulum this time. Let us see. Are you okay with this question? Alright, shall I move on? The next question, you have got a frame, an equilateral frame. Let's take the L1, L2, L3 as the length. To begin with, the lengths are actually same. I'm just calling them 1, 2, 3 so that you can identify them. This rod has a alpha is alpha 1, alpha 2, alpha 3. Again, alpha 1 and alpha 2 are actually the same, and alpha 3 is alpha dash. That means two of the rods are of the same metal. The third rod, the base rod, is of a different metal. So you can understand that to begin with, this angle will be 60 degrees. It's an equilateral triangle.